Okay.
Madam?
A very good evening to one and all gathered here. On behalf of the management, the principal, we, the Department of Computer Science Shift 2, we are happy to conduct this webinar on Go language. Distinguished participants, beloved head of the department, Dr. Sober Smiles David, my dear faculty members, and dear guest, Mr. Tejus Pratap, a formal welcome to you all. It is now evening time for us, and for the guest, it's early morning. So I thank once again for the speaker for accepting our invitation amidst his busy schedule. Once again, we welcome you all. In this situation, we have several anxieties, worries, etc. Due to this pandemic and this spread of this virus. The Bible says, casting all your anxieties on him because he cares for you, in 1 Peter chapter 5. And my dear beloved, be steadfast, immovable, always abounding in the work of the Lord, knowing that in Lord your labor is not in vain. Also, our college motto says that nisi dominus frustra, which is vain without God. So without God, we can't do anything. Now, I request our beloved professor, Dr. Mrs. Annal Elil Chelvi, to lead us in prayer. Ma'am? Ma'am?
Ma'am? Yes, ma'am. Am I audible, ma'am?
Yes, yes.
Let us pray. Loving Heavenly Father, we praise you for this international webinar on Go language and your purpose on it, Father. You bless this meeting today, all those present, as well as the college management, the resource person, and all the participants. You take what we have prepared so far for this meeting and multiply our efforts. Return it with multi-folded blessings, Father. Take care of the technical and networking supports. We submit each one of us in your mighty hands, especially the resource person, Mr. Tejus Pratap. Help us, guide us, lead us throughout the meeting, Father. We ask everything in Jesus' name. Amen.
Thank you, ma'am.
Thank you, ma'am.
It's my duty to introduce the guest who is from United States of America. He did his BSc Mathematics in the year 2005, and he did his MSc Computer Science in 2007 in our college. He is a proud illustrious alumnus of our college, and he did his final year project, and he is the one who created the bhc.edu.in website along with his classmates and with our beloved head of the department, Dr. Sober Smiles David. With the knowledge gained through the project which he has done, he has been recruited through campus selection in Expertus, a startup from Chennai, and then he moved to CTS, and then further to Tech Mahindra, Accenture, and so on. Now he is currently with Cisco Technologies. We are glad to have you, sir, and amidst us today to deliver address on Go language. Go language, open source language, easy to understand, and it also allows us to safely use memory and manage objects, etc. Let's just go along with the speaker to get a broader idea about this Go language. Over to you, sir.
Thank you. Am I audible?
Yes,
Thank
sir.
you.
Is my screen visible?
Yes, yes.
Good evening, everyone. So this is a pleasure for me. It's been a dream, really, to help my alma mater in technology, and I'm really happy to be here. So this particular webinar is about Golang, and I have been working with this language for some years now, and it's a really a very concise, beautiful language, which allows you to write very highly scalable, highly performant concurrent applications without worrying too much about how you work with other developers to maintain and to when you implement new stuff. Also, it is also really a good programming language to be used in the cloud, especially because of its properties that it is compiled into a native binary, and once it is compiled, the size of the binary is usually very small, so it is easy to deploy it across cloud, and the build times are also very small, very less when compared to other enterprise level languages currently being used, such as Java or most of the languages. So let me start. So what is Golang? Golang is an open source systems programming language that was designed in Google that, as I said, it makes it easy to build simple, reliable, and efficient software. It is a compiled language. It is concurrent, garbage collected, and statically typed. So it has features. So the creator of the language has made sure that it has features from some of the very well-known languages, such as Java. It has features from Java. It has features from taken from Python. It has features taken from JavaScript. So it is a modern language which tries to fill in the gaps that older languages created before the cloud era did not have, features that the older languages which were created before the cloud era did not have. It has a lot of these things in it. So it is apt for the new age. So in the timeline for Golang is this. It was started as a project in 2007 in Google by Robert Greisemer, who is well known for creating the JVM hotspot. Then Rob Pike, who was involved in Unix and the creation of UTF-8, and Ken Thompson, who is, as you might all know, is a very big figure, and he is one of the creators in creating C and Unix. Then so now, because of these three people who are the main designers included in the language, we now know that this language is built on the shoulders of giants who already know how things work in computer science, and they have made sure that the language is strong enough to scale, to help in all sorts of, to resolve all sorts of modern computing problems. Then in 2008, it became from a prototype to reality in Google. And then 2009, Go became public and open source. And then on, it's been used in many companies. So I'll just do a brief version history. So Go version 1 was released in 2012, 1.1 and 1.2 in 2013, and so on. So all Go releases of version 1x maintain the promise of compatibility. What that means is, if you write code in Golang 1.0, it will still run without any issues in the latest version of Golang, which is Golang version 1.15. So they promise that any code that is written in any older versions of Go of version 1x will continue to run without any issues on any major versions of the 1x branch. So let's see why Go. Go was primarily created to solve the engineering problems at Google while creating software that run and scale on thousands of servers. So it is the one of the primary languages being used at Google because of its capability to scale in a very high level. It is really good at scaling. It is, and another reason is maintainability. The code is very readable, and as I'll show you, there are some very nice things that will help in maintenance of the code as well. So in enterprise companies, the main thing that they look for while creating code is maintainability, scalability, and how people can work on it without multiple people can work on the code base without introducing too much bugs. So then scalability, then it has first-class support for concurrency, but it has explicit error handling, which I'll explain later. Then it creates a very readable code, and the builds are really fast. You cannot compare, meaning it's really fast. So most of the cloud companies use Go in the backend nowadays. So this is just a list of companies that I know of who uses Go in their backend. And it's, as I said, it's a system level language, so it is mostly used in the backend. But there are now uses of it coming up in the desktop as well. There are game software being written in Go. You can also use Go to create desktop level applications which work across multiple platforms. So what features will you find in Go? Go is really fun to learn. It has a very familiar syntax. If you are having knowledge about Java, C, or JavaScript, I think it would be easy to understand how Go works. It's a compiled language. It is also garbage collected. So as computer science students, I think you all know what's garbage collection. It has a great standard library. It is cross-platform, meaning once you write the code, it can be compiled across multiple platforms. So as long as the code is pure Go. So they do have two options. Like you can write pure Go. Pure Go is completely pure Golang, but you can also include external C-based C dependencies. If you include C dependencies, then it is no longer multi-platform. You need to have C dependencies compiled specifically for that platform. Otherwise, if you use normal Go, the pure Go, then it is guaranteed that it will work across multiple platforms. Then it has pointers like C. And another thing is semicolons are not required at the end of these statements. New line creates a new statement. And many, many more. But I guess you will all learn if you have interest. I really suggest that you should just go to online and read on more resources. What you won't find in Go. You won't find exception handling. There are no exception handling in Go. People who are very familiar with Java Java and C might see this try-catch blocks. You write 5,000 lines of code and put everything in a try-catch block. That is not there in Go. Then there is no inheritance and no generics as of now. But there are talks of adding generics into the language once version 2 comes into the picture. Then there is no method overloading. These are some of the things that you might miss from existing languages. These are not there in Go. So these are some of the building types in Golang. So actually there are a lot of types. I did not have the space to list out everything. So I just put everything in one string. So I apologize if it's not readable. The string, Boolean, int, these are all the normal stuff that you might have already known with other languages. There is a complex 64 and complex 128. which allows you to do complex arithmetic. So now I'm just, so this is how you get the, sorry. So this is how you get the code, get the tools for the language. You would have to go to golang.org and download the executable and just install it. Once you install, you should have a compiler ready in your terminal. And you would call the compiler by, not the compiler, you would call the tool by running the command go. So let's go to the code now. So when you compare with Java, it looks mostly similar, where you would have to, each Go program is grouped by packages, and the program starts with the function main. So the main entry point for the program is always the main function. So you should have a main function if you want to call the application. And it has native support for UTF-8. That is why you see the characters as is. When I'm printing, I'm saying vanakkam. And you can just paste this as is, and it will take care of the conversion, UTF-8, all the stuff. So here in the application, the code, you can see 3 parts. The top part is the package definition. Here it has to be main for the main function, package main. Then the second line, the third line is the import, where you are importing an external, in this case, it's a standard library package called FMT. FMT is, if you are interested, it will be, it is one of the most used internal package. It is like, it's one of the most used standard library packages. Then here we are defining the function. A function is defined by using the keyword func, and you say main because that's the main entry point. And in that I am passing fmt.println. I'm saying hello vanakkam, and it accepts most Unicode strings without any issues. So let's go to variables. So the var instruction is used to declare a variable. The type is defined at the end of the variable declaration. The var instruction can be used with initializers, in which case the type can be omitted, because the type will be inferred during compile time. So as I said, this language is compiled. So you can catch most of the errors or whatever declaration issues, everything during compilation itself instead of runtime. And a variable can be created without the var instruction by using a gopher. So a gopher is a special declaration like this, : =. It is some kind of, I don't know, the play by the creators of the language. So gopher is like some kind of a squirrel. It looks like a squirrel. It's an animal. So they call the language Golang. You might have seen that the logo of the language is an animal. That animal is called a gopher. And I think this particular syntax is supposed to refer to its face. If the value is known at compile time. So as I said, the variable can be created without var instruction by using a gopher if the value is known at compile time. So here you can see in the example code that I am creating 4 different variables. So here, no, actually 3 variables. So first variable is I'm using the standard syntax where I'm saying a variable of hello, which is of type string. And in the second line, I am assigning a value to the variable. You can also assign multiple variables. You can create multiple variables in a single line by using a syntax like as of number 8. You can also assign a variable without the var, by just like the line number 9. I'm using the gopher to assign the variable. And then line number 10, I'm printing all of them. Then we also have constants. I think this should be very straightforward. You use the const keyword to declare constants, and it remains constant. I don't think I need another explanation for that, but yeah. Then comes the if condition. The Go has an if conditional just like C or Java, but the main thing is unlike C or Java, you don't use parentheses to enclose your conditions. So you can see here in line number 9, 8, I am saying that I is equal to 0. This is an example. Usually you won't do this check, but yes. In line number 9, I am saying if I is equal to 0, then print hi, else print by. You can see that there is no parenthesis. That's the only difference. Otherwise, it performs similarly to Java or C. Going on, it also has a switch conditional. Again, it looks the same, works the same as with Java or C, but again without the parenthesis. So use a switch. You assign the variable, and then you do a case checks. I'm going to loops. Unlike Java and C, Go has just a single loop structure called for. You can use for to create most of the looping types that you would see in other languages. You can use for to create infinite loops. You can use for to like a normal Java-based or C-based for loops, or you can also use the for to in place of while loops. So there are no while loops in Go. You would use for with the same syntax as you can see in the third example. I'm using it as a while loop. So you would say for, and like while loop, you would pass the conditional and do your statements in it. So this is the normal for loop that you are all familiar with. You declare it like this. For I'm saying for I is equal to 0, I less than 3, print. So it will print 0, 1, 2. And this is the for loop, the infinite for loop. It will keep on running unless you say to exit out of from the loop. Now coming to functions. Functions, as I said, are declared using the func keyword. Functions can be declared without any arguments, or it can accept any number of arguments. There are also some advanced functions which accepts an n number of arguments called a variadic function. I'm not discussing it here. You can all find that out if you read the documentation, but I would really suggest you to go and read the documentation if you are interested in the language. Then a function is declared using the func keyword. So as you can see here, I'm having keyword, the function func add. I'm declaring the function add, which accepts two parameters, a and b. Both are integers, and the function returns an integer. So if you see here, the return type of the function is declared in this way. So you say function, you put the function name, you say what type of parameters the function accepts, and then you declare the type of return, and then you do the normal return. Again, no semicolons. If you put semicolons, the compiler will not throw an error, but you don't have to put semicolons. Then I'm saying function main. I'm printing. This is normal. You might all know. I'm just saying function print and then add these two numbers, and it gives a 5. One thing peculiar with Go, one thing that Go provides is multiple return types for functions. So unlike most other languages that you might know, Go allows you to return multiple values. A function can return multiple values. You can use this property in a very creative ways once you become very familiar with the language. But it is one of the big strengths of the language. So a function can have multiple return values. So you see here, I have created this function divide. It accepts two parameters, two integers, a and b, and it returns an integer and an error. So this is where I would like to introduce with the Go's error handling mechanisms. So as I said, Go doesn't provide exception handling. Errors have to be handled explicitly, and it might look a bit odd, but actually it is very effective because you handle errors before it becomes a problem. So with Java, what usually you will do is you would say throws exception, or you would say try catch and put everything in it. But what happens with Go is you handle the exception at the line that you would handle the error in the next line that you would expect an error to occur. So the programmer has to be very careful while writing the code, but if you are very careful and design the code properly, it will run without any issues, meaning it will be very stable, and it will scale indefinitely. So you have to make sure that you handle errors as soon as you expect it to happen. So the language puts a lot of trust on the programmers who write the language to do this. You can just avoid. So in this case, I'm saying if the denominator is 0, then return 0, and I'm returning an error saying cannot divide by 0. You can imagine if I do not have this check here, then the return will panic. So what happens in Go is a panic happens. They call it a panic. Panic is like a runtime error, and the program will stop running. So if you do not want your program to stop running, you have to do proper error checks. So here I am saying if b is equal to 0, return 0, which is the default value for an integer. I'll discuss that also. So the default value for an integer, and then it returns an error which says cannot divide by 0. And in case there is everything is okay, I'm returning a divided by b and a nil. Nil means the error is empty, which means the program executed properly. The function executed properly. And in main here, I'm saying result and the error is equal to divide 6 by 0. Now, since I passed the second parameter as 0, I'm checking here in the next line. If error is not equal to null, print the value. This statement is the error handler. What it does is it checks whether the error object is empty. In this case, error object will not be empty. It will not be nil, because I'm saying it will have an error object which says cannot divide by 0. So I'm printing the error and I'm returning from the program. If there is no error, then I print the result. So this is how you handle errors in Go. This might look a bit weird, bit different from what you are accustomed to, but this is very effective in reducing the number of errors that a program might have, because the programmer is forced to handle errors properly. If otherwise, you would just put a big try-catch block and say error found. But what is it? What is the error? How are you handling it? In this case, you explicitly handled errors so that the program can continue running. One more thing I would like to say here is Go has default values for most of its types. So integer default value is 0. Float has the default value of 0 again, 0.0. And Boolean has a default value of false. So what happens is if you declare a variable, say variable of type Boolean, by default, if you print the value of the variable, it will be false. Go will make sure that it defaults to a default value. Integer 0, float 0.0, Boolean false, and in case of string, it defaults into the empty quotes. So if you are declaring a variable, unlike you would say if variable, let's say animal is equal, just say variable animal, it will automatically assign the default value of empty quotes to it. So it reduces the chances of getting a null pointer exception. because most of the time what happens is people, programmers tend to forget the initialization. Sometimes in the compile time or in the runtime, you would get that error, but Go reduces the chances of getting that runtime error because the value is default value is automatically assigned to the variable. Now Go also has pointers like in C. It is very similar to C, the C-based pointers. So in this case, and the pointer is declared by using the asterisk character followed by the type of the value stored in the pointer. And here I am saying that I'm having a function which accepts a pointer of integer type, and then I am, as you can see, I'm not returning any value, but I'm trying to convert the value of A into the value of B. So here I am having a value A assigned to 1, and then I'm calling this function change me, which accepts the address. So ampersand is actually the address to the variable. When you and as a computer science students, you might know with C language also you do the same thing. So you say ampersand A, which is the address of the variable. You pass the address to change me. Now change me accepts an integer pointer. And in here I'm declaring another variable called B, and now I am pointing the address of A to the address of B. Now next time in the next line when I'm printing format.fmt.println A, it will print the value of B because A is now pointing to the address of B. This would be very useful. Pointers would be very useful in Go. It is used to reduce the memory overhead. So as you might all know, there are two types of passing values. One is pass by value and pass by reference. Go gives us pointers so that we can take advantage of the memory savings that can be had by passing by reference. So let's say if the value of A is a huge object, maybe a large file. Now, instead of passing that around in functions, which will, when you pass around into functions, it actually creates more allocation of memory. If you are doing it by reference, we are continuing to use the same pointer. So this is one thing that Go took from C and not from Java. Now, coming to some of the maintainability aspects of Go. Go is a language that supports clean code. So if multiple developers and programmers are working on a project, what happens is usually you tend to write code, unused imports, which are not used anywhere in the project, but it will pollute the source code because you have unnecessary things in the source code. Now Go helps the programmers in that. So here in this case, I am compiling a code which only uses FMT. It doesn't use runtime. Now when I compile, during compilation itself, Go will say that importer are not use runtime. So I have imported the runtime, but I'm not using it. So the code will not compile unless you remove the import statement. So this feature will help to keep the code really clean. And then there are other tools also. In this case, there is a race check. So you would say go run -race and the file name. What would it do is it would go through the file and check for race conditions, and it will help you debug the code. So besides that, there are some more features, many other features which are available in Go. Like there are structs, structures like in C. Then there are slices. Slices is like a array. I have not shown the definition of an array. Okay. Apologize for that. It should have been here. But I don't have it in the next slide, so I'm just going to talk through it. So there are slices. Slices are like arrays, but the length is variable. You can add elements to a slice. Then your range is a keyword that you would use to iterate through a slice. Then map, as you will all know, is normal. It's like a hash map. Then Go also supports closures like JavaScript. Then Go has interface support for interfaces. So interfaces is what you would use to design object-oriented code. But as I said, it doesn't support Go doesn't support multiple inheritance or even inheritance. So you would do something called composition, but it's some of advanced topic that I would not cover here. So this is a simple web server written with Go with less than 15 lines of code. So as you can see here, I'm importing two packages, FMT and net/http, and I'm having a function. So Go has the standard library, which is one of its greatest strengths. And because it's a modern language, it has most of the things that you would expect built into the language. The standard library is really strong. So in case of most other languages, older languages, what you would do is if you want HTTP, you would import an external package or an external dependency. But in case of Go, the HTTP package is built into it, and you can write a complete web server application without importing a single external package. So here I'm saying import FMT net/http. These are two packages that I'm using, and I'm declaring a function main, and I'm saying http.handle functions /hello server. So what this does is I'm asking HTTP to use the handle function to serve anything on the root, so which is the root of the website. And any request that comes to the root of the website should go to the hello server function. And here you can see the hello server function, which accepts a response writer parameter by default and a request. So you would see the request of the server, and you can write back into the response using these two parameters. This is the default signature of the handle function. And here I'm saying fprintf, the writer, and I am passing the variable. Here, what you see here, r.url.path, it takes the parameter passed to the server from the browser URL. And then I'm saying HTTP listen and serve. Here is the port number on which to run the application. The port number is 8080. That's it. Now with this number of lines of code, a web server is ready. And once you compile it, you would notice that the size of the compiled application is really, really small, and it is standalone. Standalone means if you compile, let's say if you take let's take comparison of compiled languages. Okay, so if you take Java, you would need a Java web server, a Java application server to run your Java compiled application. Let's say if it's a WAR file, or even if EAR or any other, you would use a Tomcat server or some kind of a server to run this in production, right? In production. I'm not saying that you cannot run the application on its own, but you can. But you would need a production. If you want to run it in production, you would need a good application server. In case of C, you would compile the application. You wouldn't need a production server, but you would have to take into consideration the incoming requests. You need to take into consideration many things while creating that a production level application. And then in case of C, you would have to worry about the shared libraries. You would have to worry about whatever inputs you are having, all those things. But in this case, this is a very, very good production level application. Meaning, I would say this is production level because it can handle requests from any number of people. It can handle it without any issues. And all of these things are built into the standard library and into the language. So going to the next slide. So I'm just going to refer to some advanced topics here. For concurrency, Go provides something called Go routines. A Go routine is a lightweight thread managed by the Go runtime. And Go routines provide very easy access to concurrency. So I hope you all know what concurrency is. So in case of Java, you would use threads or processes. Again, in C also you would use threads. The thing with threads is threads are usually maintained by the operating system. Okay, but in this case, a Go routine is maintained by the Go runtime environment. A Go routine can be created by calling a function with the keyword Go. That's it. So you would say Go space function name, and that becomes meaning it goes into the background and it runs concurrently. You don't have to create a thread definition. You don't have to say thread join, thread start, nothing. Just say Go and say the function name, call the function, and it will go in the background and continue to run in the background. Then I'm saying Go say hello world. I'm calling the function, I'm putting in the background, and then it runs. I'll take questions once this is finished. I'm just going to the end of the slides. So another thing is that Go provides are channels. Channels are type conduits through which you can send and receive values with a channel operator. This is also peculiar to Go. There are other languages which use this type of communication, but Go is one of the mainstream languages. So channels are very important in case of concurrency, when you are going to implement concurrency. So you see here in this case, I'm having a function square, which would accept two channels, one input channel and one output channel. I am passing these two channels and calling the function through a Go routine. What this does is a channel, in this case, the output channel will take the value and the input, output channel will respond the value and input channel will take the value in. And here I am putting this square input output into the as a Go routine. So it runs in the background. Now in here, I'm running a loop, I'm passing values into the input, and I'm printing it out. I'll just give a small introduction to channels here as well. So as you see here, this particular channel that I'm having here is similar to this syntax. I'm saying C is equal to make of chan int. So here it is the same. So make of chan int. So what is that? That is an unbuffered channel. Unbuffered channels will accept values only once the channels, meaning once the provider and the acceptor has finished their processing. In this case, you can see the provider is sending a value into the channel. As soon as the provider starts sending the channel becomes blocked. It's like you would use it in concurrency. So as soon as it, then in the number third, here you can see it is blocked, and then the receiver would take the value, and until he takes the value out of the channel remains blocked. So that is the feature that we are using here. So if you would know with threads, right? If you do not wait for the thread to complete, the thread will not finish printing the values. The program will exit. In case of Java, if you had worked with threads, right? So you would create a thread, you would call the thread, and once you have called the thread, you would have to wait for the thread to finish execution. So that is what channels does here. You are waiting, you are making sure that you are waiting for the, if you're using block channel, unbuffered channel, you are making sure that you're waiting for the execution to complete. Then there are buffered channels. Buffered channels accept a parameter like this, C make channel and 10. So in this case, this can be any number of values, and this is like a first in first out queue. So this is non-blocking. You can keep on sending values to the channel, and you can read those values by using a loop or select or many other structures available. So what I would suggest is, if you are interested in the language, go online and look into just search for Go tutorials or Golang bot. is a good resource. Golang. There is a open source book available called Golang book. It's available at golangbook.com. And I have posted the references at the end of the PowerPoint slide. If you are interested, the best thing would be to go and experiment yourself. I hope it will be a fun learning experience. So I have posted the references in the end. Yep, that brings a closure to the presentation. So if you have any questions, please go ahead.
Yes, sir. Thank you. And some questions raised by the audience or the participants. Is exception handling is a drawback one? That is, you said that exception handling is not in Golang. So is that a drawback?
So that's what I was saying, right? So each language has its strengths and weaknesses. So languages are for programmers to write the code, right? So high-level languages are written for programmers and to write the code. It's like a language. It's like a Tamil or a Malayalam or any other language. If you are comfortable with the language, you use it. So now in this case, what I'm saying is, if you say Java, with Java, they have their own way of handling errors and exceptions, right? Java has its own way. Java, what it does is it handles exceptions, errors through like exceptions, and you can throw errors around. You can say, put the exception, do exception handling. But what happens is, what Go says is, do not rely on exception handling. It is Go's philosophy. Every language, every computer language will have its own philosophy. So what it says is, once the writers of Go says, okay, if you are having errors, you handle it immediately. Don't throw it around. This is, as I said, this language was created by some of the pioneers in computer science, Ken Thompson and all. They have gone through all of these things during their entire lives in their career, right? So what they found, what they might have found is, I'm not them, so I'm just talking on their perspective. What they might have found is handling errors early is better than handling them late. In this case, we are handling the errors at the origin. So as soon as you, as a programmer, you would know, okay, you would think, when will this statement cause an error? You would have to think. So it forces the programmer to think this type of a syntax. So what it does is, you would think whether, okay, in that slide I showed you, right? You would have to think whether division by 0 would cause an error. In that case, it forces the programmer to think about it and handle the error properly, right? So I think that is a strength.
Yes. Okay. Then the next, another question is, can Go language replace Python?
So Python is a general purpose language. It is called as a general purpose language. Go is a systems language, which is slowly turning into general purpose, but it has not reached there yet. The usage of Python and Go are, I think, I don't think they cross each other, because first of all, Python is an interpreter language. So Go is not. Go is a compiled language. Another thing is, and what I would say is, Go is many times faster than Python for sure. But Python is an older language. It has a lot of libraries available for it. Go is just catching up. As I said, Go was just created in 2007. I think Python was created somewhere in 1993. So it had a lot of time to mature. Go is also mature now. It is used everywhere in production, but some of the existing libraries, such as, let's say, SciPy or NumPy, all those libraries, let's say, which are being used in Python for machine learning and data sciences, are not mature in Go. So people are working towards it. Once it's there, I think it can, it not replace, it can supplement. So what Python is mostly used for is, Python is mostly used in research. So when somebody is coming for an, like if enterprises looking for an algorithm to do some specific task, they would send it, they would take maybe scientists or somebody who works on it. They would not need to know Golang, because Python is more English-like, more verbal. So they prefer Python. So they would create the a sample or some kind of an application in Python. I'm just saying, this is the use case for machine learning. Okay, this is how it works with machine learning. So I'm giving this as a use case. So they would create the program in Python, and then when they give us to developers and programmers to convert into production level code, that is when we use system level language to convert that original code into more performant code. All right, we convert, let's say, Python code into Java or Golang or C. So in production, I don't think you would see Python running in the backend much. I have not encountered that much. So unless if it is a very huge application, you wouldn't find that. But Python is having its proponents. I'm not saying Python is a bad language. Python is a really good language. I have also used Python, but each language has its own strengths and weaknesses.
Code reusability is one of the concept that is one of the advantage of this Golang. And if inheritance is not present, how code reusability is possible?
So as I said, even though Go doesn't support inheritance, it supports something called composition. Composition can solve most of the things that you would find with that you would use an inheritance for. So, but I'm not covering that now. But I would suggest you to go online and search for Go composition. Composition in Go is like covers most of the things that you would expect from inheritance.
Okay, sir. Many of them, they have enjoyed your presentation, and they have been learned many things from this webinar. So these are some of the questions, and other questions I think you have answered in your presentation itself. So they will be able to understand. So we shall now wind up. This is the time to thank you. Big thank you, dear Mr. Tejus, for accepting our invitation and having delivered a wonderful note on Golang. Thank you, sir, for accepting and having spent your wonderful early morning time with us. Thank you. And thank you, all my dear participants from various parts of our country and from abroad. And my sincere thanks to our beloved principal, sir, for allowing us to conduct a series of webinars. And my special thanks to our beloved head of the department, Dr. Sober Smiles David, who is the driving force behind this webinar team. I also thank the team members, Dr. Anna Lelin Selvi, Dr. Tamal Shelvan, then Dr. The New Beginser, and Professor Linda, Professor Anand, for their tireless work in the conduct of this webinars. It is my duty to thank the IT support team for helping us and supporting us to conduct this webinar, and also to broadcast this webinar for the successful conduct. Thank you, one and all.
Thank you. Thanks, everyone.
Thank you, sir. Thank you.
All good.